Welcome to the Institute for Molecular Science and Engineers event for Sustainability Week. Today we will be discussing solving issues around clean water, a global challenge. My name is Elena Rabright, and I'm a research associate in the Faculty of Medicine in the School of Public Health, so right away, basically on the other campus in White City. Before we start our session, I just wanted to go through a few housekeeping rules. Today, we're going to have both in person and also online. So for the people online, if you want to ask some questions, I believe there's a Q&A panel section, and you can put all of your questions there, and we'll select them, they'll give them to me, and I'll be able to ask our amazing panel those questions for discussion. This session is part of Imperial's College Sustainability Week, as I mentioned before, and over the last 5 days, staff and students had the opportunity to hear from researchers about their work on the transition to zero pollution. Find out what Imperial is doing to reduce its own environmental impacts, and also get involved in exciting workshops and interactive events. So organized by the Sustainability Imperial, the Global Challenge Institutes, and the Imperial College Union, this year's Sustainability Week centers on the themes of climate, energy and waste, biodiversity, water and air. So now I will give a short introduction to the Institute for Molecular Science and Engineering. The Institute for Molecular Science and Engineering is one of the Imperial College London's global institutes, drawing on the strengths of its 4 faculties to address some of the grand challenges facing the world today. The Institute's activities are focused on tackling problems where molecular innovation plays an important role. This institute was set up to bring together people from all disciplines and backgrounds to solve these challenges facing our world. We believe that to be at the forefront of solving these challenges, and we need to draw upon people from all backgrounds. So we will start now our panel discussion. And first, what we're going to do is introduce ourselves. And I guess I'll go first. My name is Elena, and I have a PhD in environmental chemistry. So my main research focus is actually chemical pollution in water, which is why I'm here today. And I'm in the Environmental Research Group Department, which is part of the School of Public Health, so in White City, as I mentioned before. And what our group does is mainly develop really fast methods so we can actually monitor these compounds in the environment and see what impact they have, not only in the aquatic life, but also to human, and see the different risks and the health effect of these chemicals. Over to you.
Thank you very much. My name is Stanislava Boskovic. I'm a research associate at the Civil and Environmental Engineering. My background is in architecture and city planning, urban design, and I'm involved in 2 multidisciplinary projects, European funded projects, Horizon 2020, that have the main focus on enhancement of public health and well-being in cities. 2 projects are 4 years projects, so we are more or less halfway in both of them. One is a little bit more advanced than another with six months difference. And the first project, HEART, is dedicated on using the information, medical information, to be integrated in the planning process from the very beginning of imagining the future projects in the cities. And while the second project, UPOLIS, is focused on the implementation of nature-based solutions in very specific case studies in 4 cities from Denmark to Greece. We also have case study in Serbia and in Poland. So very different climatic, cultural scale demo sites, but with the implementation and hopefully with the introduction of blue and green infrastructure, we could improve the public health and well-being in those cities. Additionally, I'm a part of Water Systems Integration Group at Civil and Environmental Engineering too. I'm very happy to see here some of our PhD students. And we are working on the introduction of the water neutrality concept there. So yes, this is the field of my research. I will tell more about that maybe during the discussion.
Hi, I'm Tony Cass. I'm Professor of Chemistry in the Department of Chemistry, also based out at White City in the Molecular Sciences Research Hub. We were the first group to move out there. Most of my research has been involved in point of need and continuous monitoring of clinical biomarkers. So, for example, I was part of the team that introduced the first electronic blood glucose sensors, which are now used by the billion every year globally. And a few years ago, we got interested in asking the question, could we take all of this technology developed for medical diagnostics and apply it essentially to environmental diagnostics, and in particular water, because water is the closest of air, soil and water to blood, and so it looked like the easiest transition to make. Since then, we've been involved primarily in methods for sensing and monitoring arsenic in groundwater, particularly through South and Southeast Asia. And very recently, a company that I set up, AquAffirm, has been doing field trials in both Bangladesh and Pakistan, looking at how well our sensors agree with, if you like, the laboratory methods. In addition to all of the sensing side, I also am director of the Adjuvant Measurement Suite in the Molecular Sciences Research Hub, which is a suite of several £1 million worth of essentially liquid chromatography, mass spectrometry instrumentation that Agilent have established there, and is open to all users within the college.
I recommend that, so we use it as well.
Perfect.
And over to you, Nick.
So hi, my name is Nick Vulvoulis. I'm Professor of Environmental Technology and Deputy Head of the Center for Environmental Policy here at Imperial. I'm an environmental scientist by training, but mainly my research now is on environmental management, kind of the interface between policy, science, and engineering. My work is mainly focusing on themes like the water energy food nexus, water quality, but also sustainability and the circular economy. I'm currently PI in 2 projects funded by the United Nations Food and Agriculture Organization. One is on the natural resources-driven fragility, so the fragility of nations depending on their availability and demand for natural resources. And the second one is on droughts. I'm working on an exciting project of SPI, also funded by NERC, which is on the role of manufacturing antibiotics as a role for creating AMR in the environment, which is a cause of concern, and have been the policy lead for a big European project the last 5 years called GlobaQua, which focused on the implementation of the Water Framework Directive, which is the main driver for how we manage waters in the UK, what we call catchment management or river basin management. For the last 20 years, actually, I have been the academic lead for Imperial's partnership with Anglian Water. So there again, we have been looking for the last few years on the impact of sewage overflows in the quality of waters in the UK. My approach is really looking at these problems from a systems perspective. So we champion the need for integrating different disciplines and dimensions when you're addressing these big sustainability problems, and water is key to all of this, because you can see the link between most of the sectors of the economy and of what we're trying to achieve with also net zero, but also generally sustainability transformation.
Well, thank you for the brief introductions. And now let's start some of our discussion points for the day. And let's start from the beginning. Why is provision of clean water still an unsolved challenge? What is the bottleneck in solving this societal problem? I'm not sure who wants to start. Go ahead.
probably the best way.
Yeah, okay. So actually, with one is Zara Rosalie, who is one of my PhD students, we just published a paper that discusses kind of the need to address water management from a system perspective. And the fact that it's such a complex issue that sometimes we forget that it's not just engineering, it's not just science or policy. You have to really work with stakeholders, you have to work across the sectors, and that's a key driver in how things are moving. We looked at, for example, some leverage points, enabling conditions that can make a big difference. And the first one that we found was actually the value of water. So if you change, if you talk about the real cost of water, you can really address some of the kind of root causes of a lot of challenges. That was the first one. The second one was the need for public participation. So that's not currently happening well. So can we get all the public and all the stakeholders involved in the change that is required? And the last one was what was covered earlier, actually, was the need to look at more at nature and the way of incorporating nature in how we design our engineering systems. So like nature-based solutions, but also mimicking nature in how we close the loop, let's say, in the water cycle. So how our current water cycle is very linear. We abstract, we use and then we discharge, but in the future we see it kind of more water use, direct water use, when we clean the effluent to the standards that are needed for potable use, and then mimic nature in terms of how it happens in a much faster dimension.
Want to add anything?
Yeah, I can maybe just say a little bit. I think one of the issues is that we don't use water smartly enough, and I think a good example of that is the whole area of grey water. So this is water that's very slightly contaminated. And it just gets mixed in with all of the heavily contaminated water and then has to be purified back out again. And so one of the things that one of my companies is doing is developing a software that essentially lets you design grey water management systems along with the traditional fresh water and wastewater. And I think that, those kinds of things, just doing what we do already, but smarter, will also help alleviate the problem.
And I think one of the interesting points now that you mentioned, those contaminated waters that are really, really contaminated, it's about the combined sewer overflows that you were mentioning before. And I think that's also a big challenge, and the public engagement that you were mentioning as well.
Yeah, I mean, there are so many contaminants these days in our water, emerging contaminants, new contaminants at very low concentrations that we are not really sure about their health effects. We are certain about the very acute toxic effects, which we have managed to avoid, but the long-term exposure to persistent or pollutants that are there in very low concentrations is very unclear. So there is a risk with cancer, with fertility. There's lots of concerns in terms of very low concentrations of estrogens, endocrine disrupting compounds, microplastics, nanomaterials that are very low concentrations, but we cannot really predict the effects.
All those endocrine disrupting compounds, but even if they're at low concentration, they can be pseudo persistent, like you're mentioning, and then become an issue.
Yes.
Yeah, pretty interesting points. To move on a bit, maybe, I'm going to go with yours, that's okay. How can city planning and development solve issues around providing clean water? Are there any technologies that could be implemented in this stage to help the distribution of clean water?
Yeah, this is a very good transition from what you were saying to actually the focus of our work at projects I was mentioning. So I couldn't agree more than need for an integrated approach for different systems that we are dealing with: water system, energy transport system, building system, and this is extremely important from the very beginning of each project we are working on. The project seen as an intervention in a bigger system of the city, so a multi-scale approach, and the city planning can enhance that through the multidisciplinary experts team, not working in silos, each expert for their own part and maybe in a different timeline. But it's very important from the very beginning of the project, a dialogue between and creation of this systemic view of the issue and the solution, and the constant dynamic improvement of these solutions. And of course, you were both mentioning also the involvement of different stakeholders. In our projects, we have, of course, stakeholders that are experts in different fields, also medical experts, which is very important because sometimes we technically see the issues linked to public health in a different way than medical experts do. But then also we have technology providers to help monitoring both the baseline of the areas that we are studying, but then also to assess the possible solutions and then to monitor, hopefully, benefits of the interventions. And also we have, of course, academic partners as ourselves, but also the dialogue with the end users of the spaces. And in city planning, if we deal with the public space or with the new development, it is something that is really very, very important learning, not only informing, but also learning from our end users. Regarding the technologies you were asking of, and here I would link with the treatment of the water and the importance of new technologies for wastewater treatment that are there in smarter way, but and also in a very different scale that we would use to think about, because when we think about even wastewater treatment plants, we think about bulky, very big areas in the cities, while today technology can really solve it in smaller elements that could be introduced in public spaces, and they don't need to be separated. They can be multifunctional and really be expandable. We work in Belgrade case studies on a creation of educational hub where we will actually introduce one of our technology providers, partners, Biopolus from Hungary. They produce these multifunctional reactors for treatment of the industrial water, water that can be used in kitchens for cleaning it constantly, but as a part of the public space, as a part of the educational hub, not as a separate element in city. So yes, integration would be the key word in different senses.
It's a challenge, but yeah.
Yes.
That's really interesting that you mentioned about the wastewater treatment plants, because I think there's a big solution there, but I also see a really big challenge in terms of the number of compounds that you were saying.
And also,
so many chemicals.
And also, I mean, we are lucky in the Western world because we had the previous generations of us paying for the infrastructure we enjoy today, right? So that's, there is a lot of places on the planet that do not have this infrastructure and they have to build it, right? Water is a basic need. It's central to public health. So if you look at kind of the global water crisis, it's only 10% that it's used for households. You know, that's how much all you need, and it's still not offered to all the global population. So it's not just technical. They are mainly, you know, if you live in a poor country, you will not have a good, you know, water system. It's connected to the socioeconomic status, connected to institutional choices, even to poverty, mainly to poverty, but even corruption. So, you know, a lot of nations, as they're developing, they need to invest in this water because it is an enabling condition for development and for prosperity. So we shouldn't forget that.
Yeah, I agree. And we also are lacking the sense of legislation and regulation that we have in place, like the, well, now we're not part of Europe, but the Water Framework Directive. Yeah. But of course, when you leave Europe or the UK in this case, all the countries don't have the same possibilities. So yeah. Okay. So I think I'm gonna ask another question. Let's see who wants to go. What does affordable mean in relation to providing affordable sanitation and affordable clean water? I think it kind of relates to what we were talking now.
It does relate, yeah. And it's interesting. Would you like to answer? If you see the cost of treating water has been increasing. It has been increasing globally because of more pollution. You know, the waters that are available are more polluted, so we have to treat them. And also in most places, you have more demand than availability. So you have to desalinate or you have to transfer water. So on one hand, the cost of drinking water has been going up. At the same time, the cost of wastewater treatment has been going up because of emerging regulatory controls that require more and more stringent regulations in how we dispose of our wastewater in terms of emerging contaminants, in terms of pollutants. So that seems problematic. These two trends have resulted in the water use, what we said earlier, the direct water use as an emerging driver for its popularity, as an alternative supply for water. And although if you consider the cost of water use, it is more expensive than the cost of abstracting water, and treating it for disposal, and it's also more expensive than the cost of wastewater treatment, it is cheaper than the sum of the two. So when you don't have to do it twice, but you have to do it once, it is much more advanced, and at the end, it ends up being much more cost effective. So I see that, for example, in terms of cost, a better provision in the future, but through a different system in which we clean water once, and from our wastewater, we directly provide potable water, and the efficiencies are significant. But again, that's a transition that is quite challenging to happen, although it is happening in parts across the world. Everywhere else, I think countries that are developing their infrastructure now, they have to consider cost because it's a big parameter for social prosperity. And I think that's some of the options they are considering.
Maybe just add to that there has to be a willingness on the part of government and individuals to invest in water. And I think certainly in Europe, for many decades, we've been used to basically thinking it was free.
Yeah.
And as it's become more and more scarce, that's no longer a tenable situation to hold. But what the motivation is for improving matters, I think, will vary geographically hugely. I mean, in South Asia, so we've been working on arsenic measurements. A lot of the water outside of the big cities comes from tube wells that are drilled down into the underground aquifers, and it's easy to get a government grant to drill a tube well, but there's no ongoing support for maintenance and removal, and so tube wells spring up everywhere, and then essentially very rapidly become unusable because they haven't been maintained, the water hasn't been remediated. I think that's a sort of issue locally, but in different guises is probably globally significant.
And even in the UK, it's a similar problem because Ofwat, who regulates the water industry, our industry here is private, so they're highly regulated. They have kind of two conflicting drivers. One is to keep customers' bills low, and at the same time, force the industry to invest in infrastructure. And this is not easy. It hasn't been easy. And some of the problems you mentioned about overflows, it's because of the lack of infrastructure in investment in infrastructure. So it's not just the developing, but the developed world has started seeing these problems in terms of the need for increasing the price of water.
Yeah, I was going to bring the Thames and the combined sewer overflows all over London.
Huge cost.
That it will be, I'm not sure how much it's the investment they're doing at the moment, but
yeah, and it's not just even it's not even treatment, right? It's storage.
Exactly.
So it's I think it will add something like £100 per person's bills on. So it's a huge.
But of course, there's like 9 million people approximately in London, so it is hard. I don't know if you want to comment on how
well
preparing for it.
Yes, but one of the works that we are focusing on with the water systems integration group is, so if we see the prospects of housing development in London for the next 10 years, then we know that there is a plan for almost 500,000 of new housing units to be built in 10 years. So we questioned ourselves, what will be the impact on water system in this case? And of course, on demand, we analyzed 3 indicators. One is water demand, another is risk, flooding risk, and of course, water quality. And this is when we introduced the concept of water neutrality, which doesn't mean zero consumption of water, but more how to implement this new housing and how to offset this new pressure that inevitably, from the planning point of view, is coming, and to introduce this new plan that is already known for 10 years of new housing, new demand of housing. we know that, of course, we have to create this new housing with the blue-green infrastructure and with the new systems for avoid leakages of water and so on. But also to offset this, we would need to retrofit almost the same amount of existing housing, 400,000 existing housing, and also of course, to introduce additional blue-green infrastructure, almost 20 square kilometers, to really offset this impact that is going to happen. So this is why the research from the very initial point of thinking about new housing development is important for this dialogue and for knowing what this new development will really mean in terms of water quality, water consumption, and risks it takes with
So it does take years, basically.
Yeah, certainly.
And that you were saying about water quality, that kind of leads to the next question as well. On what does clean mean? How is clean have to be in order to be worth investing in? So because we talk about clean water, but it's actually,
So,
I'll leave it to you to
okay. Yes,
I'm not sure who will-
well, I mean, we shouldn't be calling it clean. We should be calling it safe,
Yeah, exactly.
right? So there is not. I mean, chemistry, you know better than. How can you say what is zero in chemistry, right?
Exactly. You can't.
You can't. So it's so. For example, in the UK, I just wrote it down. So I remember the regulations. It is mainly the water, the EU water treatment directive, that is drinking water directive, that specifies the values that are required as a minimum in our water, in drinking water. But it's the water supply and water quality regulations that has been translated into UK laws that actually specify a number of organic, inorganic compounds and some indicators that the water companies have to publish annually in monthly reports to the Drinking Water Inspectorate if they meet or they do not meet it. So that's kind of how we know that the water we drink from our tap water is safe. And interestingly, I was going to say that those levels, for example, if you think how they have been developed, for example, the levels for a pesticides, right? For a pesticide is 1 microgram per liter, 1 microgram per liter of, let's say, an individual pesticide, right? If it's below that, the water industry needs to invest in removing it, right? So how do you think this level has been set up? You know, how do we know that if it's below 1 microgram, any pesticide, if it's below that 1 microgram per liter, it is not safe, but if it's above, the other way around, it's safe, but if it's above, safe.
Yeah, which is purely arbitrary and,
Yes.
and is often determined by the capabilities of your analytical method.
Exactly.
If it's undetectable, it's safe,
Yeah.
but we know that's not the case. And
It's so important, to be able to invest as well in research and how to monitor these compounds and see the toxicology as well, because it cannot be arbitrary, like, oh yeah, all pesticides now, and there needs to be a reason and a thinking behind it. And just because you don't see these chemicals doesn't mean they are not there. They could be there, but at even a lower concentration. So, and
but even lower, I mean, Tony is absolutely right. The policymakers call it a substitute for zero.
Yeah.
It is, this value is just the limit of detection at the point that the regulations were introduced. So just that. It doesn't mean any safety comes with it. So it's just simply zero, but it's not really zero.
it is. It's not. And also, to some extent, the ability to deal with it. I mean, again, picking the arsenic experience, which I know more about than most other aspects. The WHO limit for arsenic in drinking water is 10 parts per billion, I think. But in certain countries, the limit is 50 parts per billion, simply because it can't be measured below that value, and it's too expensive to remove the arsenic. So it's an arbitrary decision. And as the analytical methods improve, so the limits are lowered. It's not specifically a water example, but antibiotics in milk. Every time an improved method came out to measure antibiotics in milk, the allowable limits were lowered. So in that case, it was very clearly driven by the analytical capability, not by any inherent property of the things you were measuring.
And this is an opportunity for research because it needs the collaboration of chemists, improving the methods of environmental scientists of understanding the fate in the environment and of public health in terms of what are the impacts of these very low concentrations.
And I was just going to say that maybe to put this into a bit of perspective, I think there's 350,000 chemicals that are registered now for manufacture and sale. So there's no way we can monitor them all, not only in the environment, but also in drinking water. That will be even at lower concentration. So yes, I think investing and trying to maybe get all of us together into how to monitor them and in a fast manner as well, because it depends on when and where you take the sample. And like you were saying, different countries might require different limits and different, so it does become a bit of a challenge, I think. I don't know.
Yeah, and the cost of doing it.
And the cost,
so
yeah.
We can employ the most
And
sensitive, specific analytical methods, but if it's going to cost you £100 a sample, you're not going to analyze it. You're not going to do that routinely.
So that links to affordability also, because apparently we're spending more on bottled water than we're spending on our water bills on average in Europe. So I think that's an interesting kind of comparison to see. And if we knew that if people had the perception that water maybe is as safe, or which is much safer, by the way, than bottled water, they wouldn't, you could transfer those costs towards public authorities.
Yeah. And it's not only those chemicals that we're targeting because they might pose a higher risk, like you were saying, some pesticides. It's also like what happens with the transformation products or degradation products from those compounds. Like if you start adding up, there's no way we can monitor them all.
No, of course.
Yeah, and there's some well understood examples where that happens. I think one of the ones is where chlorine was used to disinfect the water from microorganisms, but also reacted with some of the trace organic pollutants and actually made them more toxic. So as you were removing the microorganisms, you were increasing the toxicity of what was left.
Or the synergenic effects, when you have them, maybe they are all at really low levels of concentration, but once you put them all together, does it mean that the toxic level increases? Like it's going to be, or how do they behave even between them regarding toxicity? So I think there's a lot of research still on the pipeline.
And maybe just to connect indirectly also to spatial planning and to decisions that our research on water neutrality maybe could help also to see where to introduce these new developments that we know that will come, because it is very different if we create new developments on the brownfield. Very often question on the obsolete industrial areas, which have serious issues with the quality both of soil and water, or in air, of course, and many other issues, but or in a green field where there is nothing yet, and what is the cost occupying the green field and compare it with the reuse of obsolete areas. So really research can also help to create a scoring system, a multi-decision criteria, methods for assessing the possibilities for cities authority to know what will be the impact, in this case for water neutrality, but for many other purposes that we define as a purpose in development of the area.
Yeah, because I do think that certain countries actually reduce the wastewater, not only the sludge, but also the water for irrigation in agriculture. But I'm not sure, I think in Europe it depends on the country. And you also have to think of if these chemicals are not removed, because wastewater treatment plants are not designed to remove these chemicals. So are they going after again from the sludge into the soil, and like it creates a bit of a loop. And there are studies that say that they found contaminants of emerging concern in food, and so I think that's also
So in the UK, we don't do wastewater irrigation,
Yeah.
but we do biosolids recycling. So we put our sludge onto land. In most of the Europe, especially around the Mediterranean, where there is no water, they recycle the waste effluent.
Yeah.
And if it's not been treated to high standards, then you do have a lot of contaminants that are there. So normally you would avoid to use it in edible plants, but it's a risk, especially for pathogens.
Yeah, I do think it depends on the country, and I think the sludge sometimes they incinerate it, if not.
For the sludge,
Yeah.
currently, it's mainly anaerobically digested because we get the energy back in the UK. But of course, more destructive methods like incineration. The EU is developing a new directive for sludge for biosolids.
We have some questions online as well. So I'm just gonna go through a couple of them. For example, what could governments do on a global scale, local scale, to provide clean water? I'm not sure. What are your thoughts on this? Because we talk about the challenge of how to bring different stakeholders together and how everybody, depending on their expertise, can actually bring something completely different that we haven't thought before, and how difficult it was to engage with the public. So I guess with the government, there might be also a challenge as well. And they ask on the global scale and local scale. So both.
This is from the public. This is from the audience.
Yeah.
Yeah. Well, I think there is the need for more integration. You know, you can see sometimes that governments will see this as a water problem, and we have seen a lot of, for example, desalination in the Middle East, in countries that they do not have enough water. So you can spend on technology to introduce, let's say, have more water. There's no limit to how much water you can create from desalination. But again, you have carbon emissions if the energy is not renewable, and you have also the environmental impacts in terms of how this happens. And not only that, but the more water you produce, the more wastewater you have as a result. So you still have the problem of what do you do with the wastewater that is produced from the increased consumption. So governments really have to look at this as a system, you know, as a system, understand that it works with a lot of other factors. And I think the way forward is mimicking nature. It's mimicking nature in a way that allows you to direct and develop very efficient cycles in terms of how you use water, how you reuse it many times, still being safe, and looking at the economics in terms of truly valuing the cost of water and not leaving externalities to cover a lot of the problems, being clear about carbon emissions and costs, and of course, the need for technology and innovation in making technology more energy efficient and reducing the pollutants in the first place before they enter waters. So we're thinking of cleaning water all the time, but actually it's our activities that pollute it. So a lot of this needs to be prevention and precaution and stopping these contaminants entering the water systems.
Yeah, I think there's also an issue with government involvement where water sources, rivers, for example, cross national boundaries and recross national boundaries, and how you integrate the management of those sorts of resources, because obviously the upstream countries will want to maximize, but so will the downstream countries. And I think those problems are going to be very difficult to manage in the future as water gets scarcer. Yeah,
of course. And the impact it has not only in the environment, but like to all of the species and then to us back again. So yeah. There is a question online which is really similar to the one we had before, which I think it might apply more to you. Yeah. Regarding the technologies, which ones could you implement in this stage so we can distribute clean water easily?
Well, for the distribution, there are many. It's very difficult outside of the context to say one. And linking also to the previous question on local and global, I think it's a very important notion in city planning, especially knowing that when we are acting in one part, it has, of course, a local impact, but also it has an impact on a bigger scale. And this constant zoom in and zoom out of the intervention is something that we have have to keep in mind on every step of the designing the solutions and also applying the technology. And then also we know that the city is a dynamic, of course, system, and there are many things we can assess. Some we can predict, but we also know that solutions that we are introducing in city and technologies have to be adaptable, elastic, expandable, because the conditions might change.
Yes.
So in this sense, I would underline the importance of the context where we are in either Europe or other countries to then know which technology could be
To be more
implemented.
affordable.
Exactly.
What is the role of a research intensive university in a developed country in delivering clean water globally? Big question.
It's a very big question.
I'm not sure who wants to.
I mean, I think you could pose that about almost any global challenge that does not specifically to do with water. I think the role of university researchers is to innovate and possibly to translate. But you need a pipeline of innovation such that, a bit like sort of a pipeline of new pharmaceuticals, that, you know, there are many promising compounds that fail to make it as a drug. There are many promising technologies that will fail to make it as water management. But in the end, I think the role of the universities is to fill that pipeline. And I think that's what we do best, and that's what we should largely stick to doing.
It's going to be challenging for universities also, because I think a lot of these global problems require a lot of interdisciplinary solutions. They require a transdisciplinary understanding of the problems. And I think that's something that we have not been really confident in developing. You know, many universities are good in disciplinary knowledge, so that's a new challenge for people. Kind of, how do they work together? How do they look at problems across sectors? For water, for example, you know, we think that water problems are related to people, but most of water is used for food production. You know, 70% globally is for food, and even at the UK's households, you know, 5 times more water per day we use for the electricity we consume, and about 10 times more for the food we eat, which is mainly imported. So we have to almost see the dimensions across kind of the global economy and find interventions that enable, let's say, these interactions between sectors, make it easier for have transparency in material flows and how water is used, and put in good economic value that reflects the true cost, let's say, of the things we enjoy and in our world.
And getting the expertise from each sector.
Exactly.
Yeah. We have another question from online, which is a bit long, so I'm going to try to do it slow. What do you think about the role of measuring household water more accurately with the latest technology and sensors? For example, measuring water at the point of application, for example, taps, rather than having one household water meter.
I suppose I should look at that. I think it's actually quite difficult to do, and I think the reason for that is that sensors fail, and so it is, you know, you're shifting the problem to the households to maintain suitable quality sensors. And, you know, what happens if it suddenly shows lead in the presence of your drinking water, not because there's lead there, but because there's a sensor malfunction. And so I really, unless the sensors themselves become much more reliable, and they'll have smart diagnostics that will tell you whether the sensor's behaving properly or not. I think there's better use of resources than being worried about what's coming out of your tap because of a sensor reading.
To calibrate them and everything.
Calibrate them, maintain them, and it's, I mean, again, taking an analogy from a different field, but from clinical diagnostics, the continuous glucose sensing, now a 14-day wearable that will give you a continuous readout of the glucose in your blood, it's fantastic technology, but it's taken 40 years and $40 billion globally to get that far. So yeah, it's yeah.
There is a potential, let's say, in the future of using water technology, like you use energy technology emitters, for example, to kind of calibrate your demand. So when you see high demand, you encourage people, or you make them pay less for their water, more for their water. So you kind of try to play with the demand aspect of water, but that's quite far away, and water is not as connected as energy. But overall, I agree with Tony in a way that we're focusing too much on household consumption when it's a very small percentage. In the London alone, the same amount of water we use is lost in leakages, every year. At the same time, most of the water, as I said, goes to agriculture and to our food production and to energy production, and food production in countries that do not have water, right? So a lot of our foods are imported from countries that they do not have enough water to feed, to serve their people, not producing goods for us.
Yeah. So how to distribute that into the different sectors? Yeah. So we have another question. Where do you see your research going in the next 5 years? And this for all of you. And what excites you the most? So I'm not sure if you want to start, maybe. Yeah.
I can start if it's okay. So yes, I was mentioning about water neutrality concept we are working on, and now we are focusing on what is the area where the new developments could be implemented in a way to offset the water demand and also to guarantee quality and reduce risk. Our future steps are also not only to see where we can do it, but also how. Does urban morphology, like the shape and the form of the new developments, has to do with also the water consumption and the water quality. So yes, connecting the spatial characteristics and where in city we can work better, and also what are the future typologies, the future way of life. We know that the system even of housing is changing. So how can we include it through the lenses of water neutrality?
So what does it excite you the most, like to see it from the paper into, I guess?
Yeah, well, the implementation, yes, and the improvement in quality, and hopefully being able, yes. Exactly.
And for you, Tom?
Yeah, I think in the next 5 years, was it? So it's always 5 years. Everything is 5 years away. But I think on that time scale, it will probably be incremental changes that are being made. Maybe more water metering, domestic appliances that use less water. I mean, these things you don't actually notice, but cumulatively could have a big effect. What excites me particularly when I put on my analytical scientist hat is the use of advanced analytical methods, not just to tell you about water quality on the output side, but also to tell you things on the input side. I mean, we learned during COVID that you could predict the incidence of COVID by looking for the virus in wastewater. That had been done for decades for polio. And it's being done for drugs like cocaine to identify drug use in. So I think that's really where my interests lie.
And I find excitement and looking at the role of the Internet of Things or digitization in helping us understand the water systems at real terms, and kind of using it also to change public perception. So kind of have this information of how you use water, where is it coming from, where's your food coming from, how was it grown, where it was produced, what happens to it when you dispose of it. I think all of this information, as the public gets more and more engaged with this evidence, changes really kind of how we do things, and hopefully they will help us to move into a more sustainable future in which we are all empowered and engaged in understanding really the true impacts of our activities, and therefore change our behavior in some ways.
hopefully for the team I mean at the moment, to be able to continue monitor these compounds and see if we can have more knowledge of them and see how, with the help of public engagement as well, see how that relates into policy, hopefully, not only for the environment, but for us as well, for our health. So I think we're coming about to time now. So I just want to thank everyone for coming and the panelists today. So big applause. And so thank you everyone online as well, and for those questions. And before we leave, I'm not sure if someone from here will have a question or, oh, we have one, yeah.
I'm from University of East London. My name is Abhimod. I'm studying MSc International Relations. So I would like to know that I'm just going to get into the threat that the world is going to face due to the polar ice melting. So there are many germs that are hidden, that is dormant state in the permafrost. So how can we tackle that? Getting into the river waters in the course of time, because it's melting at a faster pace than before.
I'm not sure who wants to take the lead.
I'd say a little bit maybe first. That's a somewhat hypothetical thing to worry about, and I'd say, I mean, people have speculated whether, with the thawing of the tundra in North America and Russia, you'll release the influenza virus from the 1918 pandemic that simply lay dormant. But I think that the real problems are much more immediate than that. So I think, it's innocence until proven guilty. And I think at the moment, there's no evidence for what you're saying. We should be aware of it and alert to it. But I think, we've got other things to worry about that are more immediate.
We cannot predict these things that might happen, but we still should be prepared for we have the systems that like we've now developed for COVID, for all these risks that we are ready when and if they do happen.
I'm not sure if we have maybe 1 minute. Yeah, do we? Yeah, perfect. Yes, go.
My name is Michelle from 8 Hours Ahead. I just had a quick question for you. Could you speak to the effects of aging infrastructure on clean water?
Yeah, I mean, I covered it because we recently published this paper on this. So we showed that is a big problem for developed countries. The US has committed a huge budget on dealing with this infrastructure recently. In the UK, we have this conflict between consumer, bills and infrastructure. So there should be a review of how much we need to spend to keep up our infrastructure with the demand and also the quality of water is required. And globally, there is obviously a huge need for investment in countries that do not have this infrastructure. So one of the Sustainable Development Goals is exactly on that. We are actually running behind with progress in that Sustainable Development Goal globally, but countries need to focus on helping these countries to develop the infrastructure, which is critical for their prosperity.
Yeah.
The operation and maintenance of water system in developing countries. Yes, the community are asked to look for operation and maintenance, but what could be more robust and operation and maintenance of drinking water system in developing countries? In rural areas, where there is no distribution as such.
Yeah, you go on.
No.
Okay. Well, I mean, traditionally we've done the mistake of going to the developing world and just, giving them a technology to pump water out of the ground, and that's it. And that doesn't work because that runs out very quickly. The wastewater that's produced contaminates a lot of other sources. So we have to help them develop technologies that can be sustainable, that can produce clean water, that can be collected again, reused. So there is this trend of looking at even avoiding the mistakes like we did in the developed world, and looking from a fresh start, these technologies that help you to run the water cycle, let's say, making sure that you don't create more problems by giving people access to properly contaminated water or water that is running out.
I think we have time, I'm sure. Yeah, we do? Okay. Yeah, and then.
We ask them both at the same time.
No, you can start and then.
Yeah, thank you. So I have a question for three panelists because you all mentioned about the ideas of cooperation, like the Nick mentioned the closed loop, and Tony mentioned the smart water, and Stanislava mentioned the integrated system. So I want to ask, so in which aspect you think is the most important one, or the most difficult one to cooperate to solve the clean water?
I'm not a civil engineer, so it's very difficult to answer that, but I would probably retrofitting to already existing housing developments, the tools and the methods for better utilization is going to be the most challenging. It's always building a new town is easier when it comes to handling water because you're putting everything in fresh, whereas retrofitting to Victorian house in London with piping that's rusting, and I think that's going to be one of the most difficult things. But apply solutions that have been developed for new installations of infrastructure to existing ones.
But you are right. I think even look at the organizations like Imperial. These problems require more than simple collaboration. So we have a new theme, the pollution, the net zero pollution, which aims to almost coordinate how these people should collaborate and what the real challenges are, and bring them together to talk about. So it's not just collaboration; it requires some sort of coordination, some sort of integration, and therefore you almost need to establish the problems first. And these initiatives all help with having more impact.
Well, I agree with both panelists, and also I would like to add that what will be a difficult part retrofitting, which is always complex, but also to align timescales in solutions and in their implementation, because the time that we invest in research, in design and implementation is longer than the conditions and changes in urban systems are happening. And once it is implemented, it could already be obsolete or less agile than it should be. So this is why another excitement in research, in modeling processes, and in testing these solutions before anticipating that long time span is something I believe we can improve and try to minimize that problem.
And I think I'm just going to add to that to policy. I think policy is one of the most important that can help us quicker. We have already the data, we have all of the expertise, and people have shown in so many papers loads of different problems. So I think now we need that policy to be strict and those governments to come together and say, okay, this is it, we need to change. There needs to be a change, and they need to be made, I think, a bit more strict. There are certain compounds that we know that they are toxic, and the government doesn't let them use them for something. Like, for example, there's a pesticide, imidacloprid, that it was banned in the UK in 2018. You cannot use it for agricultural purposes, but you can use it as a pet parasite, parasiticide. And there's so many cats. There's like 11 million cats in the UK. So you still have this compound in the environment and in the river, not from agricultural purposes, but for another one. So I think the policy there, it's hard, but there needs to be a bit of a balance as well. And yeah, that's my point. And I think the last question, we come back to you.
It's not a long question. If I want to start recycling my grey water, where should I start? Or doing something with my grey water.
Probably water the garden.
Is there anything I can't put on the garden?
From grey water. Yeah, no,
well, there'll be loads of personal care products and compounds there from your cleaning products and everything. So
But it wouldn't work, you know, because for recycling to work, it means that you are not, you stop using something else. So if your water, it's better to put it in the system so it gets properly recycled, unless you use it for something that avoids, you know, clean water use. So maybe if you had a car or something, or if you, yeah. So I think that it's not down to so much to the individuals like recycling, which is a big thing in terms of our waste. With wastewater, you have to have systems in place to. You know, I have a person in my bathroom. The sink flushes my toilet, but it was a very expensive device. I bought it just for the sake of doing it. You know, when I refurbish my flat, but I wouldn't encourage you to buy it because you know it doesn't really save that much. And as I said.
And I think from the washing machine, there's also loads of microplastics from all the clothes and everything that we wash. So I'm not sure. I mean, as long, I guess, that you don't eat anything that you plant in your garden, you're still putting it to the environment. So maybe splashing it so it goes through the proper treatment would be actually the most, I think.
But Tony said I could put my washing up.
It's just like all of these chemicals that you will be using in your detergents and everything. There's loads of personal care products, like, yeah, even like shampoos and everything we use. So I don't know. Yeah.
Technology is much more efficient than us. So there is a research that a dishwasher, it's much more efficient in saving water than doing it by hand.
Yeah.
Anything that requires you to leave the tap on takes a lot of water. So think of that.
Good.
Yeah.
Okay, I think that's it, and I hope we are in time. So just to remind you that the last Sustainability Week event will be held today at the Union Bar, and apparently there will be loads of different workshops on conscious consumerism. I think this is also from someone from White City from my department, and there's also drinks at 4:30. So thank you everyone, and online as well, and the bandwidth.